Chapter 4 deals with trigonometry and the functions of trigonometry. Well, trigonometry is the study of angles and triangles. And so first off, an angle. Looks like that. That's one thing. This point right here is called the vertex. And this is a side, and that is a side. Well, for the purpose of this class and input, we need to put them in standard position. And a angle is in standard position when the vertex is at the origin. Which is 0, 0. And one side is the positive x-axis. That side is called the initial side. The other side is somewhere else. It is called the terminal side. So if we were to take this angle here and put it in standard position, it would be right there. There's our initial side, and there's our terminal side. Now, the other thing about an angle in standard form is it has rotation to it. So when you look at an angle, you can't just assume that the angle is this opening from here to there, because an angle can have rotation to it. So we could be talking about this angle from there to there, but we also could be talking about this angle that goes from here all the way to there. Or we could be talking about the angle that starts here and goes all the way around and then stops there. Still has the same initial and terminal side. Or possibly we could have an angle that starts here, goes all the way around that many times, and then stops there. Similarly, it could be one that starts here and goes around and then stops there. Those are all different angles, but with some of the things that we're going to do later on, they kind of have the same properties. So because angles have rotation, we have to know which angle we're dealing with. And for now, I'm just going to leave the first two up there. This angle that rotates counterclockwise is a positive angle. positive angle rotates counterclockwise around the coordinate plane. This angle that rotates clockwise around the coordinate plane is a negative angle. And so you have to determine which angle you're dealing with. Now, some terms you should remember from your days in geometry would be an acute angle, which an acute angle is greater than 0 and big and smaller than a right angle, or 90 degrees if you're talking in degrees. There's an obtuse angle, which is an angle that is greater than a right angle, but less than a straight angle, or between 190 and 180. There's also a right angle, which is a 90-degree angle. And you have a straight angle, which is 180 degrees, or a line. Well, then there's a couple other special words that you need to know, and a reflex angle, which would be all others. So like this pink angle here, this one, that is a reflex angle because it's not between 0 and 180 degrees. And then we also have something called a reference angle. And the reference angle is an acute angle with one side on the x-axis. So a reference angle for this orange angle, whether you're talking the pink one or the blue one, the reference angle is this angle right here. Now, if we have an angle that starts here and ends here, whether it is this angle that goes this way or that angle that goes this way or the one that goes like that, doesn't matter. The reference angle is this angle right there because it's an acute angle made with the x-axis. And if your angle were to start here and be down here, well, then your reference angle is this one right there. Same thing as if it's over here. If that's your angle, and say it's that one right there, well, your reference angle is this one. All right, so we kind of started talking about it here with these definitions of acute obtuse because we talked 90 degrees and 180 degrees. So there are ways that you can measure an angle, and one way is in degrees. With degrees, 1 degree is 1/360th of a complete revolution. And so that means there are 360 degrees in one revolution. Or you can say there's 360 degrees in a full circle. So that means if you look at this, then this all the way around is 360 degrees, and it could be divided up into 360 line segments to make all the different angles from 1 to 360. Now, because there's only 360 degrees in a revolution, you have to have a way to get between this angle and that one. So there are decimal parts of a degree, or partial degrees. And for partial degrees, if you do not have it in decimal form, they are in minutes, first off. And how many minutes are there in a complete revolution? Well, there's so minutes. The symbol for minutes is like the foot sign. So there are 60 minutes in 1 degree. And then there are also seconds. And the symbol for seconds is 2 little things, like the inches thing. And there are 60 seconds in 1 minute, which means there's 3,600 seconds in 1 degree. And so you have decimal parts of degrees. So let's say you have 25 degrees, 15 minutes, and 30 seconds. And you want to know what the decimal form of that is. Well, to do that, you just need to add 25 plus, and then 15, because it's 15 minutes and there's 60 minutes in a degree. Divide 15 by 60. And then also add 30 seconds, which means 30 has to be divided by 3,600. And when you do that, you will get 28 or 25.258 degrees. So that is how you convert from degrees, minutes, seconds to decimal form. You can also convert the other way, from decimal form to degrees, minutes, and seconds. So for that, let's say you have 54.495 degrees, and you need to write it into degrees, minutes, and seconds. Well, to do that, first, you already have the degrees. It's 54 degrees. So get rid of the 54. You don't need that anymore. Then we take the decimal point 495 and we multiply it by 60. So when you multiply by 60, that's 30, carry the 3, 57, carry the 5, and it's 29.70. So now this becomes the minutes. 29 minutes. And finally, get rid of the 29 and take 0.7 times 60, which would be 0.42, so then it's 42 seconds. Now, if you multiply by 60 the second time, if you get like 42.8, well then you'd write 42.8 seconds. The other thing about this is, when you're doing this up here, you divide by 60 for minutes and multiply by 3600 for seconds. Well, here you multiplied by 60 this whole thing, and then you took this part and multiplied that by another 60. So actually, this multiplying by 60 and that multiplying by 60 is multiplying by 3600. So it's the same thing, it's just you're doing it in two different pieces because you got to stop at this point to get the minutes out of there. So that's one way to measure degrees. We won't spend too much more time on that because I think you should understand how to do that by now. The other way is with radians. And the radian measure of an angle is the length of the arc divided by the radius of the circle. And so we have to think about a circle when we're figuring out the radian measure. So if you're given an angle, well, the first thing you have to do is get the center and make yourself a circle. So then this would have to go all the way to there, and that would go all the way to there. And so then the radian measure is the length of this divided by the radius. Now, let's say that this is 5 right here. So then the length of this we would have to calculate. Well, completely around the circle is the circumference, and the formula for the circumference of a circle is 2 pi times r, which in this case is 5. So that is 10 pi. And then we would have to know what this degree is in order for us to figure out the length of this arc. So whatever that degree is, then you would have to multiply the angle by 360. And then, because you're taking that much of a 360 degrees. Well, if we're just looking about the complete circle all the way around, the length of that arc is 10 pi. And then if we divide that by the radius, which is 5, you will get 2 pi. And 2 pi is the radian measure, which is the same as 360 degrees. So all the way around the circle is 2 pi, or 360 degrees. Meaning, if you cut that in half, pi is equal to 180 degrees. So in your circle that's on the coordinate plane, this angle, this straight angle, yes, that is 180 degrees. The radian measure of this, doesn't matter what the radius is, this thing, if you take the radian measure of it, because the length of this arc divided by the radius, you are going to always end up with pi. And pi is approximately 3.14, and then a bunch of stuff after that. And if you were taking this and going from here all the way around to there, that is 2 pi radians. And 2 times pi is like 6.28 and stuff. So in a circle, if you're just estimating things, it is approximate, it's pi to there, so that's like 3.14, so 3 is about right there. So basically this is cut up into thirds, and then 6 would be somewhere in here. So because it's 2 pi all the way around, so 6 is about, so 1, 2, there's 1 radian, there's 2 radians, there's 3, 4, 5, 6, and this is 6.28 all the way around it. And that's how a radian is shown. Now, when you look at an angle, if you see the degree symbol, it's in degrees. If you see something in terms of pi, then it's in radians. If you see some plain old number like 4, that does not have a degree symbol up here, so therefore that is 4 radians. It's not 4 pi, it's just straight up 4, which 4 is approximately this angle from here to there. That is 4. Okay? Now then, we can use this fact here to convert from degrees to radians or radians to degrees. If you have a degree measure and you want to convert it to a radian measure, well, you then have to take the degree measure and multiply by pi over 180. And if you're going the other way, if you're going to have the radian measure and you're going to convert it to degrees, you would multiply by 180 over pi. As an example, 30 degrees is times pi over 180. Well, let's see, simplifying this, take out a 10, and then 3 goes into 18, so it becomes pi over 6. Now, if you want to know what that is as a number, well, then you would take your calculator and check 3.1415249 and stuff and divide it by 6. You're going to get 0.5 something. If you have 90 degrees, you want to convert it to radians, you multiply by pi over 180, and you will get pi over 2, which is approximately 1.57. And then if you're going the other way, let's say you have pi over 5. If you want to know what that is in degrees, you would multiply by 180 over pi. And so that turns into, the pi's can divide out, you got 180 divided by 5, which is 36 degrees. Okay, then next thing, let's go back here for a second. When you're dealing with radians and having to draw, hopefully you deal with degrees and you have to draw a picture of an angle in degrees, you can handle where that needs to be. Just remember, if you have something like negative 28 degrees, well, on your coordinate plane, negative 28 would be like that. If it is in radian measure, like say 3 pi over 7, if you're trying to draw 3 pi over 7, understand from here to there, oh, let's get rid of that. From here to there is pi, which if you're going to write that as a fraction, that's like 7 pi over 7, because that's just 1. So that means this is divided up into 7 equal spaces. And 3 pi over 7, let's see, if this is 7 from here to here, that's 7. Then this has to be 3.5 pi over 7 because it's halfway. And this would be 10.5 pi over 7. So then 3 pi over 7 is roughly there, that angle right there. Now if you have something like a negative 15 pi over 4. So here's your coordinate plane. That means since 4 is in your denominator, it divides this up into 4 equal things. So 1, 2, 3, 4. Same with the denominator. 1, 2, 3, and 4. That's 4 equally spaced things all the way around. So if 4 is half, 8 is all the way. So then a negative 15 pi over 4 would mean we have to go that direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Here is negative 15 pi over 4 as an angle, which then we would have to do this, and it goes all the way around until it gets back to there. There is negative 15 pi over 4. All right, moving on to the next thing. Coterminal means they have the same initial and terminal side. So a 250-degree angle would start here, and there's 180, 270, so 250 is approximately there, and it's this angle. So if we want to find a coterminal angle, that would be this angle from here to there. And let's see, it's 360 all the way around, so if you subtract 360 from this, you are going to get a negative 110 degrees. That's a coterminal angle. Now, if we also have to find a positive angle that is coterminal, that means we would have to start here and go all the way around the circle and then stop right there. So that angle would be adding 360 to it. And 360 plus 250 is 610 degrees. So that's 610. Now, if you want to find more coterminal angles, you can just keep adding 360 to this. So then that makes that 970, and if you add 360 again, you would get 12, 13, 30, and add another 360 would get you 1690, and if you add another 360, that would get you to 2050, and so on and so forth. So 970 is another coterminal angle. 1330, 1690, 2050. Do the same thing with the negative angles. If you subtract 360 from that, you're going to get a negative 470. If you subtract 360 again, you're going to get a negative 830, and so on and so forth. So now, negative 40 degrees is, here's negative 40 degrees from there to approximately right there, with that angle being negative 40 degrees. Coterminal, there's the first one. Well, if it's 360 all the way around, 320 positive is coterminal. And then other coterminals that are positive would be 680, and then 1040, and then 1400, because I just keep adding 360. Well, now if I want to find another coterminal angle that is negative, that would be this way around. So that's a negative 400, and then a negative 760. And then if you subtract 360 from that, that's a negative 1100, and so on and so forth as well. If you're dealing with things in terms of pi, so let's say we have 3 pi over 5. So if we're going to draw it, that means our top half of our circle is divided up into 5 equal parts. So this is 5 pi over 5, 0, and then if you go all the way around, that's 10 pi over 5. But we only want to go 3 pi over 5. So 3 pi over 5 would be, let's see, this is 2.5, so 3 pi over 5 is right there. This angle. So coterminal would be this angle right there. Well, this is 5 pi over 5, and then this is 5 pi over 5 all the way from there to there, but we have to take away 3 pi, so that's this 2 pi over 5, 6, 7, 8, 9, 10 would be all the way around. So we have negative 7 pi over 5 is coterminal. Another angle that is coterminal would be this one that starts here, goes all the way around the circle, and then back to there. Well, all the way around the circle is 2 pi, which is 10 pi over 5, and then 3 more, so 13 pi over 5. And then another angle that would be coterminal would be is if you keep adding 10 pi over 5 to it, so 23 pi over 5, add another 10 pi would be 33 pi over 5. And on this one, if you subtract 10 pi, it would be a negative 17 pi over 5, and so on and so forth. Now then, let's say you had 3 pi over 7 as your angle. Well, 3 pi over 7, let's see, is going to be here, because 3.5, this is 7 from halfway, then 3.5 is the up part of the y-axis. So now the angle there would be, let's see, it's 14 all the way around. 14 pi over 7 is all the way around. So an angle would be a negative 11 pi over 7. Positive angle would be this one that starts here and goes all the way around to there. So it's 14 all the way around plus 3 more, so 17 pi over 7. And then we'd have to add, so another one would be 31 pi over 7. And another negative angle would be a negative 25 pi over 7. So that's what coterminal angles are. Complementary angles make a right angle, which means they're 90 degrees or pi over 2. Well, if the angle's in degree mode, I hope you don't have any issues trying to find the complement of it. But what if it's like pi over 5 and you want to find the complement? Well, now here's where your subtraction of fractions comes into play, because you have pi over 2 minus pi over 5. Common denominator in this case would be 10, and pi over 2 becomes 5 pi over 10. Pi over 5 becomes 2 pi over 10, and 5 pi minus 2 pi is 3 pi over 10. Now, if this would have been, say, 4 pi over 5, well, then you would have 5 pi over 10 minus 8 pi over 10, which is a negative angle, and you can't have a negative angle be a complement. So if your angle is bigger than 90 degrees, there isn't a complement for it. Supplementary angles, they equal a straight angle, or 180 degrees, which is pi. So if we have pi over 5, we would have to find the supplement. You would take pi minus pi over 5. Well, getting common denominator again, this time it's 5 pi over 5. So 5 pi over 5 minus pi over 5 is 4 pi over 5. And if we were to change this to, say, 4 pi over 5, well, then that would be 4 pi over 5. And 5 pi over 5 would be 1 pi over 5 is the supplement to it. If that gets to be bigger than pi, then there is no supplement. Finally, the length of an arc. Well, we know that the radian measure equals the length of an arc divided by the radius. So therefore, If you solve for length of an arc, you would just multiply by the radius, so the radian measure of an angle times the radius is equal to arc length. Now then you aren't going to put it into words, and you shouldn't try to remember it in words. Radian measure of an angle is theta, usually. That's the Greek letter, theta. It's basically the radian measure of the angle times the radius equals arc length. Now, if you do not have the radian measure of the angle, if you have a degree measure, say you have a 40-degree angle, and you know that the radius is 2, well, you can convert this to radians, which would be 40 pi over 180, and then the zeros cross out, and 4 goes into 18, 2 goes into that, so it's 2 pi over 9 times 2, which turns into 4 pi over 9. That would be the length of the arc. And that's with the circle, where that is 2, and then that's 40 degrees. That's this answer right there. How long is that thing? Now, if you don't want to convert it to degrees, or from degrees to radians, you can take 2 times pi times the radius times the angle divided by 360. This ends up being the same thing as that, because 2 and 360 turns that into 180, and then you can cross a 0 out and cross a 0 out, and then 4 and 18 become 9 and 2, and oh, and this is 2 already. So you have 2 times 2 over 9 times pi, which is that right there. And finally, the area of a sector. In the area of a sector, you would have 1/2 r squared times theta is the way that you figure it out. Now it's pi r squared times the angle over 360. That's the same as this right here. So again, if you have a 40-degree angle, convert it to 2 pi over 9. And then if the radius is 2 still, multiply by 2 squared times 1/2 equals, let's see, that's 4, so that's going to be 8 pi over 18, which is going to turn into 4 pi over 9. And that is the area then of the sector. And so that we're talking this circle. And if this is a 40-degree angle, or 2 pi over 9, the area is 4 pi over 9, which 4 times pi is roughly 12, and 12 divided by 9 is 1 point something. And so that's the area. And that is everything in this first section. I know it seems like quite a bit, but you'll get quite a bit of time to practice it so you have a better understanding of it all.